Example 4, it says the surface ships in the figure have determined the indicated distances. So you can see that we have this ship over here at point A. I'm going to call this over here point B. I'm going to call this point down here point S for submarine. And I'm going to call this point up here point P. Just so I have the ability to refer to things. All right. Can make that P bigger maybe. That's point P right there. All right. So it says, first use the law of cosines to find the measure of angle A, then use SOHCAHTOA to find X. So the concern of these people in the ships is how far down is the submarine. That's what they want to know. And the specific distance straight down to the bottom of the ocean here where the submarine is P to S, right? So we're trying to find the length of this piece. And that segment lives in a right triangle. As you can see, there's a right angle right there. There's a right angle right here as well because the straight line has two right angles on it. So the triangle APS, if I just look at that triangle, APS, I'm going to bring it over here. If that's the problem in my book, I'm probably going to be transferring stuff over to my paper here like this. So APS, and this is X that we're trying to find. Okay? The directions very clearly tell me that I want to find angle A using the law of cosines. So if I'm focusing on triangle ABS, and this is 615 feet, and this is 499 feet, and this is 629 feet.
Wait, is the 615 the whole top or just that one?
Yeah, 615 is all the way across. We have no idea how big that little piece or that little piece is. If we did, we could use SOHCAHTOA right off the bat, right? So if I knew that this little piece was 615, and that's 499, I could probably use the Pythagorean theorem to find X, right? So, and plus the problem would be 499 would be the hypotenuse shorter than a leg, so it would work anyway. But yeah, but 615 is all the way across, not just the little piece. All right. So looking at this, this is a side setup. So angle A is over here in this corner, and it matches the angle A in this right triangle. So the strategy they're telling us to employ here is to use the law of cosines to figure out what angle A is. And once we know what angle A is, we have the hypotenuse, which is 499, and we're trying to find the opposite, right? So if you take a look at this just the way it is, this is the opposite side to A. This is the hypotenuse of the triangle. So I know that sine of A has to equal opposite over hypotenuse. I can't use SOHCAHTOA yet because I don't know what angle A equals. There's too many variables. I'm only allowed to have one variable when I'm working SOHCAHTOA, right? Yes. So variable 1A, variable 2x, too many variables, so SOHCAHTOA is not going to work yet. But once I determine what A equals by the law of cosines over here, then I know what A is. I can put that number right there. Now it's workable. All right, so again, that's the strategy. That's what we're going to do. So if I'm doing law of cosines to find angle A, and I set my law of cosines up like I normally do, I'm going to have the cosine of A all the way over here. It's, of course, being subtracted by 2 times a couple numbers times that, right? And then what goes over here has to be the side opposite A. So if this is cosine of A, the number by itself has to be 629 squared. And when you're setting the law of cosines up, that's the relationship you need to make sure happens. The angle over here on the left has to match this side opposite all the way on the right. Then what goes in the middle is just a bunch of numbers squared and 2 times numbers and so on. So 629's here, so that means one of the two numbers, I'm going to go 499 squared goes here. The other number 615 squared goes here. And then 499 goes here and 615 goes here. It doesn't matter if this goes first or that goes first. They're being added together. Addition's commutative. It doesn't matter if this is first or this is first because multiplication is also commutative. So within those objects, it doesn't matter where those numbers end up. Just like I showed yesterday in the homework problem that I went through today as well, this piece of the law of cosines has cosine of A attached to it. It's going to be separated from all the numerical pieces. So when I evaluate all these numbers to powers and so on and so forth, I need to keep that highlighted object separate from all the other numbers. So 629 squared equals 395,641. 499 squared is equal to 249,001. 615 squared is equal to 378,225. And then -2, notice negative's the first number I'm typing, so -2, I use the negative key, times 499 times 615 is -613,770. So -613,770 cosine of A. And again, be sure to keep the cosine of A term separate from all the other numbers. You cannot add and subtract these numbers with that number. That has to stay separated from everything else. Okay, next, I want cosine of A, that term by itself, so I'm going to bring everything that isn't cosine of A to this side, starting with the addition and subtraction parts. So I'm going to do minus 249,001 and minus 378,225. And I'm going to keep the negative 613,770 cosine of A on the other side. So 395,641 minus 249,001 minus 378,225 comes out to negative 231,585. And that's going to equal this piece all by itself, negative 613,770 cosine of A. Notice both sides have negatives on them, right? The left side's negative because the subtraction created a negative. The right side's negative because it was negative. So now when I divide both sides by negative 613,770, I'm just going to get negative 231585 already in my calculator divided by negative 613,770 equals. So cosine of A is going to be 0.3773. And since we know what cosine equals, to find what A equals, I have to do the inverse cosine. So I get my calculator, say second cosine of 0.3773. And A comes out to a 67.8335 degree angle. Again, be careful. This says cosine equals, so I did inverse cosine. If it says sine equals, I'm going to do inverse sine, tangent equals inverse tangent. So the trig function involved in the expression tells me which inverse trig function to evaluate. So now, going back to this other triangle APS, which is this little piece out here, I now know this angle here is 67.8335 degrees. And that means by SOHCAHTOA, opposite is what we want to know, hypotenuse is what we do know for the angle 67. So sine is what I'm using, that's why I got that. So now I'm going to have sine of 67.8335 over 1 equals x over 499. Okay. Just replace A with what A equals. My calculator knows that the sine of 67.8335 is equal to 0.9261. So now if I cross multiply, this product, x, equals that product, whatever it is, 0.9261 times 499, 462.1239. So if I go a couple decimal places, 462.12 feet. And I know it's feet because everything else is feet, right? Feet, 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 so this is feet. And that'd be my final answer to the problem. as a general rule, we're in trigonometry. That's what this chapter is all about, is trigonometry. Trigonometry is the study of triangles. You need to envision triangles in your pictures. Any picture you see given to you, whether it's a triangle drawn or not, like this one, you can see the triangles very clearly in the picture. The golf problem we did, I had to draw the extra piece in to create the triangle, okay? But envision triangles and everything. Write down what you know in the triangles and then use the given information to establish how to figure it out. If you get angle, angle, side, angle, side, angle, or side, side, angle, the law of sines can be used. If you get side, angle, side, or side, 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 the law of cosines can be used. If you have a right triangle, SOHCAHTOA can be used. All right? If you can use SOHCAHTOA, it's usually easier than the other two things. So if you have a right triangle, start with SOHCAHTOA. But then when SOHCAHTOA fails to get you the information, maybe you have to use the law of sines or cosines to get more information. Right? So keep that in mind, that you have all these tools to use. It's a matter of knowing when to use them and using them properly when you do. So keep that in mind as you're doing the word problems on this section, and keep up the good work on all this stuff.